Hey friends, welcome back. Architecting Gen AI solutions. Single LLM call versus RAG versus agents is one of those topics where a single qualifier word changes the answer. Today we'll see exactly why. Let's get into it. A team I'll call DataDino shipped a dinosaur chatbot that confidently told a school group the T-Rex went extinct 65,000 years ago, off by a factor of 1,000. The fix took weeks, because the team had reached for a 5-agent supervisor architecture when a single LLM call with retrieval would have done the job. By the end of this video, you'll know exactly when to reach for a single LLM call, when to wrap it in retrieval-augmented generation, and when you genuinely need an agent. Quick bridge from earlier episodes. We covered prompts as contracts, and we covered foundation model selection, Llama, Claude, and embeddings. Today we zoom out one level to the architecture wrapping the model. The model and prompt are set, and the question is what you build around them. 5 terms anchor this whole video. A standalone LLM call is a single prompt in, single answer out, with nothing else attached. A deterministic chain is a pipeline where you, the developer, decide the order of steps. An agent is the opposite. The LLM itself decides which tools to call and when to stop. A tool is a single-typed function the agent can invoke, like a Unity catalog function or a retriever, and a multi-agent supervisor is one LLM routing work to several specialist agents underneath it. Keep these straight, because the rest of the video is about choosing between them. DataDino's museum chatbot just told a visitor that a particular species went extinct 66 million years ago, confidently, cited like a fact. Except the paleontology team revised that date last month based on new fossil evidence, and the chatbot has no idea. The team's first instinct is the wrong one. Fine-tune a custom model on dinosaur facts. The senior architect pushes back. The right answer is RAG over Mosaic AI vector search. Cheaper, faster, and every answer cites the chunk it came from. The lesson here is that no model upgrade would have fixed this. The architecture was wrong. Hold this thought as we go through the rest of the video. The architecture is the most consequential call you make. Pick the wrong one and no model upgrade. Not a bigger Llama, not Claude 3.7 Sonnet, not anything can save you. Pick the right one and a smaller, cheaper model usually does the job just fine. Architecture is the lever. The model is the engine that lever moves. Here's the spectrum. On the left, a standalone LLM call, one prompt in, one answer out. The model speaks from its training data, cheapest, fastest, but blind to anything new or proprietary. In the middle, RAG, retrieval augmented generation. The system retrieves relevant chunks from a vector store, injects them into the prompt, and grounds the answer in fresh, cited data. On the right, an agent. The LLM itself decides which tools to call, in what order, and when to stop. The most flexible, but also the most costly, the most non-deterministic, and the hardest to debug. The rule is simple. Pick the lowest tier that meets the requirement. Every step right makes your system more capable, but also slower, pricier, and harder to reason about. 3 ways to answer a customer question. A standalone LLM replies from whatever it remembers from training, fast, but frozen at training time. RAG adds a retrieval step first, then answers using what it found. An agent reads the request and decides at runtime whether to retrieve, query a database, or call an external system. Same underlying model. What changes is the workflow around it, and how much that workflow costs you per request. Here's the Tier 1 rule. If the answer already lives in the model's training data, and the task is 1 turn, summarize this paragraph, translate this email, classify this support ticket, then a single LLM call is the right answer. Adding retrieval to a translation task buys you nothing. Adding an agent on top of a summarization task buys you latency and complexity. When the model already knows, just ask, So why did DataDino's senior architect reject fine-tuning? Look at the left side. Fine-tuning bakes today's facts into the model weights. The moment paleontologists revise an extinction date, those weights are stale, and retraining is expensive. There's no citation trail either. So when a visitor asks where the date came from, the chatbot can't show its work. Now the right side. RAG pulls fresh chunks at query time from Mosaic AI vector search. Update the underlying delta table, and the next answer reflects the new fact, no retraining. For the museum chatbot, this isn't even close, and every response cites the source chunk, so auditing is built in. Now here's a mindset shift that trips up a lot of engineers. Architecture choice doesn't happen at the project level, it happens at the sub-task level. A business goal like improve customer service is not one task, it's 3 or 4 atomic things stitched together. Trying to force one monolithic LLM call to do all of it, or one bloated agent to handle all of it, is where over-engineering starts. Decompose first, then pick the right pattern for each piece. Watch the decomposition happen. A customer writes in, "My order is late and I'm furious." Step 1. Detect the sentiment. That's a single LLM call with a structured output schema, returning something like sentiment equals angry. Step 2. Look up the relevant FAQ. That's a RAG step against the support knowledge base, pulling policy chunks. Step 3. Draft the reply. That's another LLM call combining the sentiment signal and the retrieved chunks into a tone-matched response. 3 subtasks, 3 different patterns, 1 feature. And notice, the steps are known in advance. Sentiment always comes first, retrieval always comes second, drafting always comes third. That makes this a deterministic chain, not an agent. The developer decided the order, and that's exactly right. Here's how the Databricks documentation defines a deterministic chain. Read it carefully. The key phrase is at the end. The developer defines which tools are called, in what order, and with which parameters. The developer defines the order. Hold that phrase in mind, because the comparison coming up next pivots on exactly that word. And here's the contrast in one sentence. The LLM adaptively decides which tools to use, when to make more LLM calls, and when to stop. The model decides, not you. That single word, adaptively, is the entire difference between a chain and an agent. Side by side, here's what changes. On the chain side, steps are known at design time. Every run follows the same path, and testing is straightforward. You can write unit tests for each step. No surprises in production. On the agent side, the steps depend on the question being asked. One run might hit the SQL tool twice, another run might only call retrieval. You need tracing to see what actually happened, and you need iteration limits so a runaway loop doesn't burn your budget. Use an agent only when control flow must genuinely vary with the input. If the steps are fixed, you don't need a model deciding them. You've now got the 3 tiers in your head: standalone LLM, RAG, and chains. The rest of the video goes deeper on the tier engineers over-engineer the most. Agents, specifically, the case where the model itself drives the control flow. Before we talk about agent design, kill this anti-pattern. On the left, hand-rolled conditional parsing. You prompt the model, get free text back, run a regex to fish out an intent string, and branch with if-else logic on what you extracted. It feels clever for about a week. Then the model's phrasing shifts slightly, your regex misses, and the whole pipeline silently routes to the wrong branch. Format and parsing errors are a major and well-documented category of agent execution failures. On the right, structured tool calling. The model itself emits a JSON payload naming the tool and the arguments. The framework dispatches the call directly. No regex, no string matching, no guessing. This is a built-in mechanism in every modern foundation model. Use it. Here's what a tool call actually looks like on the wire. The model returns a tool calls array. Each entry carries a type of function, a unique call ID, and a nested function object. Inside that function object, the name field says search_exhibits, and the arguments object carries the query string and a top K parameter. Your framework sees this, looks up the registered tool called search exhibits, and calls it with those exact arguments. No parsing, no ambiguity. The contract between the model and your code is JSON, stable, validated, and machine-readable. This is what makes a tool calling agent strictly safer than any hand-rolled conditional chain. Now the single most important distinction in this video. A tool is one capability, a function, a query, a retrieval call. An agent is the orchestrator that picks among tools stored inside agents. They are not peers. When an engineer says I need 5 agents, one for SQL, one for the web, one for RAG, one for the internal API, one for summarization, they almost always meant I need one agent with 5 tools. This is the production mistake. Conflating the two is what turns a clean architecture into a tangled, expensive one. Here's the analogy that makes it stick. Tools are kitchen appliances: a blender, an oven, a fryer, a scale, a thermometer. The agent is the chef, the one who decides which appliance to grab for which step of the recipe. You do not hire 5 chefs because you happen to own 5 appliances. You hire one chef and equip them well. But here's what happens in practice. Engineers default to hiring chefs when they should be buying appliances. Every time you feel the urge to add another agent, ask yourself, is this a new chef, or is this just a new appliance the existing chef should be using? Here's the same workflow drawn 2 ways. On the left, what to do: a single agent with 4 tools attached: SQL, web, RAG, and a generic API caller. 1 LLM call per turn, with the lowest token and latency cost. On the right, what to avoid: a supervisor agent on top, 4 specialist agents underneath, each with their own prompt and their own LLM calls. 5 calls per turn, plus the handoff overhead between them. Same outcome, but every extra agent multiplies your token spend, because the conversation context gets resent through each one. Each handoff also adds somewhere between 100 and 500 milliseconds of latency. 5 capabilities almost always means 1 agent with 5 tools, not 5 agents behind a supervisor. Let the numbers land. Single agent token usage sits at roughly 1 times baseline. That's our reference point. Multi-agent token usage balloons to 5 to 10 times that, because the full conversation context gets resent through each LLM hop, and every additional agent pays the full context cost again. And added latency per agent hop reaches up to 500 milliseconds, often over half a second of delay before any real work begins. For a startup like DataDino, where provisioned throughput budget is already a meaningful constraint, the difference is the difference between a feature that ships and a feature that gets shelved. One more line from the documentation, because it's the discipline behind every decision we've made in this video. Start simple. Introduce more complex agentic behaviors when you truly need them. That sentence is the difference between a system that ships and a prototype that doesn't. Here's the design primitive. Tools are the unit of agent capability. When you need your agent to do something new, query a new database, hit a new API, run a new calculation, you don't spin up another agent. You add a tool, a typed function, a clear name, and critically, a description the LLM can read, because the description is exactly how the model decides whether to call your tool. No description, no call. One concrete consequence of what we just covered: a tool with no description is invisible to the model. You can register the perfect function with the perfect arguments, but if the docstring is empty, the agent never picks it. The comment isn't documentation for other developers, it's the API contract with the model itself. Here's a tool defined as a Unity catalog function, DataDino's check license tool. The function takes an article ID, returns a license string. But look at the comment block. It doesn't just say what the function returns, it explicitly tells the model this must be called before retrieve article, and it enumerates the possible return values. That comment is what gets passed to the LLM as the tool description. The model reads it and learns the ordering constraint without you writing a single line of orchestration code. The function and parameter comments are doing real work here. They're encoding behavior, not just documentation. Watch this play out. A user asks DataDino's summarizer agent to summarize Article 42. Step 1. The agent calls check license with article ID 42. The result comes back open, meaning summarization is permitted. Step 2. Only now does the agent call retrieve article, pulling the chunks from vector search. Step 3. The agent summarizes those chunks and returns a cited summary. The order is enforced 3 ways. The system prompt tells the agent licensing must come first. The tool descriptions reinforce it, and retrieve article itself refuses to run if a recent license check is missing from context. Notice what we did not do. We didn't add a license checker agent and a retrieval agent behind a supervisor. We added one tool with a strong description, and the existing summarizer agent followed the constraint. Generalize the licensing example 1 level. Whenever a guard must run before an action, a license check, an auth check, a compliance gate, the order of tool calls is part of the correctness spec. Encode it in the system prompt and the tool descriptions, and let the agent enforce it on every request. So when does a multi-agent supervisor actually earn its place? 3 situations. First, when domains are radically different, a legal reasoning agent and a code generation agent really do want different system prompts and different tool sets. Second, when tasks are naturally decomposable with clear handoff points, research, then critique, then write. Third, when you genuinely need a verifier or a critic agent for redundancy on high-stakes outputs. For everything else, one tool calling agent with 4 to 6 well-described tools is the right answer. The supervisor pattern stays reserved for that rare, high-stakes subset. For today, the lesson is restraint. The full ladder has 5 rungs. Start with standalone LLM when the knowledge is in the model and the task is 1 turn. Climb to RAG when you need fresh, cited, or proprietary context. Climb again to a chain when you have multiple steps, but the order is fixed. Climb to a single agent when the control flow itself depends on the input, and only climb to multi-agent when you can prove one agent can't handle it. Every rung up costs you money, latency, and debuggability, so climb only when forced to. 4 things to carry out of this video. First, pick the lowest tier that meets the requirement, and climb only when forced to. Second, decompose vague goals into subtasks before choosing any architecture. Third, always prefer structured tool calling over regex on model output. Fourth, one agent with n well-described tools beats n agents behind a supervisor. Now let's see how well this landed with a quick 5-question quiz. Question 1. A team is building a system that must query a delta table, call a public weather API, and search internal documents to answer customer questions. The order of operations depends on what the customer asks. Which architecture is most appropriate? Is it A, a single tool calling agent with a SQL tool, a weather tool, and a retrieval tool? B, a deterministic chain that hard codes delta query, then weather call, then document search? C, a multi-agent supervisor with a SQL agent, a weather agent, and a retrieval agent? Or D, a standalone LLM call with the question pasted into the prompt? Take a moment to think about it. The answer is A. Because the control flow varies per question, you need an agent, not a chain or a standalone call. Between a single agent and a supervisor, the Databricks guidance is to start simple. 3 capabilities means 3 tools belonging to one agent, not 3 separate agents. The supervisor pattern would multiply latency and cost without buying any new capability. Question 2. A museum chatbot is hallucinating dates because paleontologists frequently revise species information. Every answer must cite its source. Which architecture best fits these requirements? A. Fine-tune a foundation model on the museum's curated dinosaur dataset. B. Deploy a multi-agent supervisor that routes between a facts agent and a citation agent. C. Use a standalone LLM call with a longer context window. Or D. Build a RAG pipeline that retrieves chunks from Mosaic AI vector search at query time. Take a moment to think about it. The answer is D. Two requirements drive this. Data changes frequently and answers must be cited. Fine-tuning bakes yesterday's facts into the weights and exposes no citation trail. A standalone call has no fresh context at all. The supervisor is wild over engineering for what is fundamentally a retrieval problem. RAG pulls fresh chunks at inference time and naturally surfaces the source, exactly what DataDino's senior architect chose. Question 3. An engineer wants their agent to call a compliance check function before any data retrieval function. What is the correct way to enforce this ordering? A. Add a separate supervisor agent above the retrieval agent and compliance agent. B. Write Python if-else logic that inspects the model's free text output and dispatches accordingly. C. Encode the ordering in the system prompt and in the tool descriptions, including a refusal in the retrieval tool when no compliance result is in context. Or D. Fine-tune the model on examples that always call compliance first. Take a moment to think about it. The answer is C. Ordering is a design property of the agent, enforced through 3 places. The system prompt instructs the order, the tool description text reinforces it, and the retrieval tool defensively refuses if the compliance check hasn't happened yet. Adding more agents doesn't help. It multiplies cost without enforcing anything. Regex on free text is the brittle anti-pattern this video warned against, and fine-tuning is the wrong instrument for procedural rules. Question 4. DataDino's agent already answers questions about dinosaur exhibits using a vector search tool. The team now wants the same agent to also surface current ticket prices from the pricing database. What is the correct first action? A. Add a well-described pricing lookup tool to the existing agent. B. Spin up a new specialist pricing agent behind a supervisor. C. Fine-tune the model on historical pricing data. Or D. Replace the agent with a deterministic chain that always queries pricing. Take a moment to think about it. The answer is A. Adding a tool to an existing agent is the simplest, cheapest, and most reversible change. A new specialist agent behind a supervisor is exactly the over-engineering pattern this video warned against. Fine-tuning is the wrong instrument for live pricing data, and a deterministic chain throws away the agent's flexibility for the other exhibit questions. When a new capability is needed, the first move is always, add a tool. Question 5. A team needs to classify the sentiment of an incoming support ticket, retrieve relevant policy from an FAQ, and draft a reply. The 3 steps always happen in the same order. Which architecture is most appropriate? A. A deterministic chain, sentiment classifier, then RAG retrieval, then reply drafting LLM call. B. A single tool calling agent that decides per ticket whether to run each step. C. A multi-agent supervisor with a sentiment agent, retrieval agent, and drafting agent. Or D. A standalone LLM call given the ticket plus the full FAQ in the prompt. Take a moment to think about it. The answer is A. The steps are fixed in advance. Sentiment first, retrieval second, drafting third, every single ticket. When the order is known, you use a deterministic chain. An agent would add non-determinism without adding capability. A supervisor would multiply cost for no gain. And a standalone call loses the per-step structure that makes the system debuggable. Climb the ladder only when forced to. All right, That's architecting Gen AI solutions, single LLM call versus RAG versus agents in the bag. Subscribe for the next episode of the Databricks GenAI Engineer Cert. Give the video a like if it helped, and I'll see you in the next lesson.